Hi. I wonder how many people will jump scared with that. Hello,
Just
hello
like
everyone.
just like the first 3 frames
Yeah,
of
the first 3 frames are just gonna be death. But they're like pretty quick, so like it might maybe nobody even seen it, like as we'll see in a sec. Um, hello, is there anyone in the chat? Hello? Don't see anyone posting yet. Maybe nobody saw a jump scare and now it's gonna be a mystery. The people like what happened? Hello, Nordvik.
Norway and
Hello,
Jello.
Shilo Jello, and happy holidays. Yes, like we're kind of well. I'm festive. You need festive stuff.
I know
Hello,
I need like
Connor.
a winter I need a winter coat or something.
So before we love the thumbnail, yes. Okay. So yeah, that's a Gmod color. Hello. Hello, Tatsu. Hello, Nuki. Hello. Actually, before we start, I have a question. How many of you got jump scared by like the first 10 seconds of the stream? Did anyone see the thing that we did, or was it too soon? I wonder if anybody got a jump scare. No, didn't see. Chill, scariest moment of my life. Perfect. Like we have traumatized at least one person, which means we're good to start. So hello,
Yeah.
well, and welcome everyone. I'm Froox, and I'm here with Syra, our engineering intern. This is the 4th episode of the Resonance, which is essentially, here's that word. It's essentially sort of a hybrid between office hours and podcast. We're here to answer questions about Resonite, whether it's like technical questions, whether it's more general about Resonite. You can also ask us some personal stuff here and there if you'd like to get us know more. Um, and we're also going to be doing a bit of like kind of like rambling, talking about like more general vision of Resonite, like where the platform is going, where it's coming from, sort of like very high level view of it. And also going like into a lot more technical details on things. We are actually streaming from the pre-release build because thank you so much for a subscription, Shilo. Um, and I lost my train of thought. We're on the pre-release build because the new particle system that I've been working on, called Photon Dust, is now in pre-release testing. And I kind of want to give you a little bit more kind of, a little bit of a showcase, show like how it works, and also a little bit like, deeper dive, how does it actually work under the hood, to help you understand how is it put together. The system will very likely be released to the public builds starting next week. For the, while we'll still do testing, it's going to exist alongside the old system, so we can like, kind of use both, and it helps like, anybody do testing without having to switch builds. Once we're kind of comfortable with like the system working properly, the old system is going to be removed and it's only going to be Photon Dust. So we can like use like this kind of stream as a little bit of a primer on it as well. We already seen like lots of people playing with the system, making like really cool, making really cool like visuals with it. Like it's been like some popping on Twitter. I might actually show some of them as well. I have like the video saved. But with that, let's get started on the questions. And once we kind of field some of them, we'll see like if it happens naturally or if we just have a cutoff point and be like, okay, we're gonna talk about Photon Dust and showcase it. So before, just not before. Just so like make sure your question. Oh my god, there's even more. Thank you, Phineas Former, for the subscription, and thank you, Ty Whitehall, for the subscription. Thank you.
Yeah, thank
Um,
you.
just to make sure, like your question pops up on our thing here. We have like this cool panel built by Chuck the Fox author. Make sure your question actually ends with a question mark. That way it pops up on our pinned messages, and we don't lose it. And make sure like it is answered. So with that, we can get started. So the first question is actually Corey 2099. They're saying, gasp, VR Sire, what's the occasion? What's the occasion, Sire?
Well, I figured, I missed the last stream and so I might as well not miss this one and be extra here instead of just a little guy in desktop.
Yeah. And good face tracking with all the. It's actually kind of. I'm gonna get to Jack's question next because this one's also kind of related. Grand UK is asking: is Sire on Linux right now or Windows?
I am actually on Linux right now. I'm using the really cool open source streamer software called Wyvern. That's Wivrn. Um, it's really really good actually. I actually just wrote the face tracking to work on Linux too with Resonite Steam Link integration. It like sends it in the same format so it can recognize it.
It's really cool. They were extra expressive. So I have to keep thinking about looking at the lens instead of the preview.
Yeah,
It's kind
I
of
keep
messing
doing
with
that
my
too. I'm
brain.
like,
We need to make it so it's kind of like in front or something. But anyway, so
yeah.
that, yeah, like it's always been like on like Linux. So like you've been like trying to get like Linux, to work with VR really well for like a while, and they've been getting fruits of your labor. We've actually been like we've
Yeah.
been literally talking about it like like right before the stream started. Like Sarah joined. Um, Climber J also like thank you so much for the subscription. Next, the one I skipped, Jack the Fox Author. Does the red nose help you navigate through Unity's particle code? I wish. So here's the problem. We don't have access to Unity's particle code. So like, I cannot look how it is implemented. Because in order, for to convert anything you've built with the legacy particle system, I have to write a conversion code that takes, the settings and converts it to a Photon Dust equivalent. While doing that, I've discovered some nasty rabbit holes, like where, for some reason, in certain modes, Unity's own particle system coordinate system doesn't match the rest of its coordinate system, which made it took a lot of kind of pulling hair to figure out what's even happening and why things like looking different and why things like misaligned. Um, it's it's been pain, but I've gotten through it. And the hardest part about it is like because we don't have access to the source code, I can only mess with the Unity system, try different things, observe its behavior, and from that infer how is it working, which is extra painful process. But maintaining content compatibility is like one of our highest principles. We hate breaking content compatibility. We if you build something, we want it to work. Regardless if we even if we change complete system, we want it to work as much as possible. There's like a few gaps there, but most things will generally not keep working, and it's one of the reasons like why we put so much effort in maintaining that compatibility. There's actually part of testing that Photon Dust is right now is making sure the compatibility works. So people have been throwing lots of different items on it, helping to isolate where are the discrepancies and differences, and we'll be resolving hopefully most of these or all of these before the actual switch happens. And also this one I've been kind of hoping for this one because Grant asked me this one in the moderation office hours that were happening right before the stream. Grant UK is asking, so Froox, what's your favorite pizza? And I do in fact have a very, I'm actually gonna stand up for this one too, and I'm kind of out of frame with that. I guess okay, I'm not gonna stand up. I'm gonna sit down. I didn't think that through. What I'm gonna tell you, my favorite pizza is not favorite because of how it tastes. It's favorite because of how people react to it, and I'm gonna spawn it in a second. Let's see. My favorite pizza is the USA pizza. So
No.
there's this store that that delivers pizza in my city, and on their menu I saw the USA pizza. It even has little USA flag over here, and look, it's French fries on the pizza. And I've shown this picture to a bunch of my friends from the US, and everybody's like, "What the hell is this?" And then like two people independently of each other were like, Froox, you need to buy it so you can 3D scan it. And I was like, say no more. So one time I was hungry and I was like, I'm gonna do it. I'm gonna buy the pizza, see how it is, just so I can 3D scan it. And well, there it is. I opened the box and I was kind of expecting, golden fries and everything. And I look at it, I'm like, I was hoping this pizza will strike terror into people's, hearts, and instead, this is just gonna make them cry. But I guess, it's just what it is. But then, I started showing this around to people, and I've started getting, reactions like this. Like, this is, Minx over here, and this is literally him, like 5 seconds after seeing the pizza for the first time, and I'm like, this is why this is my favorite pizza, because I've only had to suffer eating it once, but now I get to pester people with this forever. And this is why it's my favorite pizza. Also, another interesting fact, you might be, noticing there's some corn on the pizza. You see, corn is heavily subsidized in the US, therefore it belongs on the US pizza. You're welcome, Grant. I hope this answers your question to your satisfaction. And I'm gonna delete this abomination. All I can say, the reactions I've been getting have been well worth the $7 I paid for the pizza. Its value keeps growing over time.
It's like horrible and like stale and milky and gross looking on the scan.
I need to reprocess it with Gaussian splatting.
Oh boy, yeah, you sure do. You sure that's an option you can take?
And this is also why I was looking forward to the question. I was like, Grant asked me like in the live stream, and I was like, ask me on the stream because I'll show you. So I hope, Grant, that you are satisfied. So hopefully going to more serious question, Dusty Sprinkle is asking, is there going to be a second round of phase 2 tests for Photon Dust? It feels like conversion process probably needs some work, but I don't know what minimum viable concept for it. There's not really like any rounds to testing. Like usually when we do testing, it's sort of a continuous process. So we get the reports, of like compatibility issues, and then we just kind of keep releasing builds and fixing things up and ask people, please keep testing more, please keep testing more. And once things kind of quiet down on the reporting and we're like, okay, like there doesn't seem to be really any issues, everything like we tried like works, all the issues have been resolved, or most of them have been resolved, because in some cases, there's gonna be some discrepancies that like might be not worth fixing. Like if things look close enough, but there's a little bit discrepancy, we can let some things slide. But it's very case by case basis. But the gist of the process is we just keep testing until we're comfortable with it. Once we are comfortable with it, we release it to fully. So there's not really like multiple phases. There's just gonna be kind of continuous like updates with it, like builds, and we're gonna always say, this build fixes this and this, it fixes this and this, and then ask people to test some more. And once it kind of gets quieter, like we're like, okay, this is in a good state. Next question, Finas Farmer. Question, it seems my avatar is more expressive in VRC using VR15 than Resonite using Steam Link. Is it just my imagination or is that true? So I think that's probably to do with like, what blend shapes you have mapped. It's kind of hard to say in general, but all of the blend shapes that you get from face tracking, depending on the device you use, should be available in Resonite. So my guess would be that some of them might not be mapped on your avatar, because there's like two parts to the process. One of them is Resonite kind of feeding whatever face tracking data it gets into the generalized input system, and the other part is actually mapping those blend shapes, mapping those weights to the blend shapes on your avatar. And for that, like Resonite, it has a heuristic process. It tries to guess which blend shapes correspond to which ones. But that process is not perfect. So sometimes it kind of misses a bunch, and you have to assign them manually. It also might be just a question of strength. Like for example, the values in some cases, they might be too weak. One of the reasons we kind of do it is because sometimes. We've had cases where how do I put it? Where on some avatars essentially the blend shapes were overdriven. So we kind of tend to like make more kind of conservative defaults, and then like people kind of tweak it from there. So um, it could be kind of combination of these things.
Yeah. I mean, I don't know. I think I look pretty expressive, and I'm using like the Steam Link stuff or the Steam Link standard at the very least for face
Yeah,
tracking.
all the data like should be there, so it's probably just a question of like how it's mapped on your avatar. So that might kind of require some tweaking to like get it look the way you like. Next question, Grand UK. Have you considered having something like a community manager and team to act as primary point of contact for a team so they can focus on making the game? Not as exclusive point of contact, but first point of contact. We do have like some people like in those kind of roles. Most of the stuff it's kind of spread out because we have different departments. So for example, we have the moderation team. They've just done their office hours, and they kind of they're sort of the point of contact for moderation like things. We do have people who handle our marketing, Chroma and Ariel, and they've been kind of like people like they've been like kind of talking with the community, especially about like promoting Resonite and so on. Um, uh, so it's kind of it depends. We also have like business team. So for that one, we actually have a business email and we have like a form on our website, and that goes into shared inbox. So multiple people on the business team can see those. And I know like Bob, Prime, and sometimes Geens have been fielding lots of those. Canadian Geeks has been doing some as well. So it's kind of like it's a spread responsibility, like depending on what kind of contact it is. Because if you wanna talk about some kind of business thing, there's people on the team who are better to talk to. If you want to talk about moderation issues, there's like different. If you want to talk like in general, like it kind of depends. I would maybe like ask like can you clarify a little bit more, like like what kind of contact like are you thinking of? Next question is Glavin VR. How long do you think it will take to get through the audio optimization, and what will all need to go through with the odds and stuff to get the net 9? Um, so in order how long it'll take, we generally don't do time estimates because like it's hard to do them and we don't want to commit to timelines like we're not confident we can keep. My general expectation of the audio system is it's gonna take less time than the particle system. There's not as many kind of moving parts to it, and there's not as many kind of compatibility things to get through. The main part of like doing the audio system, there's like things like handling the audio rendering, like spatialization. That's probably gonna be a big chunk of it. My plan there is we actually utilize the Beppo physics structures to like do stuff like query what audio sources are at this point in space, so we can efficiently get a list of them, and then like we do whatever processing through Steam Audio to handle the spatialization and whatever else needs to happen. There's also like one part that Sire already worked on, which is the reverb zones, because that's one of the features we kind of have, and we need to like preserve it in some way. So Sire has done some research on like the libraries and have like integrated the Zeta like reverb like library, so we can actually process audio data with it, and also done some like mapping, like where each of the presets we have for the reverb zone, you found like something that sounds the closest. Like we want to like talk about it a little bit more.
Yeah, so I actually just recently went back and touched it up again, and it's actually I implemented it such that like you can process like batches of samples now rather than having to do one at a time. So
Yeah.
it's way faster. Like I can process like 5 minutes of audio in like 10 seconds, like on a standalone program. It's crazy.
Oh yeah.
Um, but yeah, I found it's not like a perfect mapping because like I looked into like some solutions with like some like even like using like training a neural network to try and interpolate the parameters. Um, but the it's kind of just going to be like a closest estimate where
Yeah.
like if you have a certain preset like set for the audio, I've gone through and I've made equivalent presets in the Zeta reverb, which is provided by sound pipe, which I believe is also provided by, just giving credit, the library is made by someone named Paul Batchelor. They're cool.
Yeah.
Um, but oh dear, I've lost my train of thought. Uh,
Yes.
where was I? I was at the. Oh yes. Um, yeah, it will. If you have a certain parameter set, like sewer pipe or like long hallway or whatever, it'll choose the equivalent Zeta preset. Um, but I couldn't find a good way to like interpolate them because they're
Yeah.
just not directly translatable.
Yeah, this is like
There might be
it's like one of those
there might
things where I like in part like I kind of like regret making the choice, like making just the reverb zone available as is, because now it's a kind of like a complicated point where the reverb is very specific to the solution that the Unity uses and makes it harder for us to translate. But we can kind of get close. We still kind of get the similar vibe for it. Um, and like and going forward we're gonna have our own audio system, which means like we now fully control the process, and then we can make sure compatibility is maintained long term. Because even say like we offer more reverb kind of solutions, more different like reverb filters, we can still keep this one because it's a relatively simple library. We have the full integration with it, and we can have there be a toggle. So that kind of gives us better way kind of going forward. But the audio system, it's one of the big parts that kind of needs to be done, but I would expect like much smaller than like the particle system because there are as many moving parts. They also kind of avoided like adding more to it because if we added more to the existing audio system, then we would have more things that need to rework, and it would essentially make it take longer. And we knew like we knew that this would eventually happen. The good part is also like the audio system, similar to the particle system, it's a hybrid. But most of the things for the audio system are actually being handled on Froox engine. The parts that need to be reworked is like where we actually send Unity, the audio data for individual audio sources, to like play from particle point in space. But like all the decoding, buffering, everything that already happens within Froox engine. We have our own handling, for like different audio formats. We have handling, for resampling, things like that. So those things we don't have to rework. We just have to like move the actual spatialization and rendering of the audio, to our, to Froox engine, and that way, like it's not gonna be tied to Unity anymore. After the audio system, the actual integration with Unity has to be reworked. I'm not gonna go super into details because I've done that on the previous episode. I've also published like a video on our official Resonite channel, which goes on the performance, where I've kind of drawn, some kind of like diagrams and so on to give you better understanding. So I don't want to like spend time on this one. If you're interested in more in depth, I recommend watching it. It's going to give you much better understanding how the performance update happens and what steps need to happen for it. But reworking the unit integration is the other part. That one I also don't have estimate on how long it's going to take. It's one of those things, where it's kind of like its thing, and then like we need to spend time kind of like pulling it apart, be like, okay, this. I have some general idea, but like we'll try to get through it as fast as we can, essentially.
Yeah, I can see why you like playing with audio stuff though, because it's like
It's fun.
I kept just listening to my music
Yes.
through it once I implemented it. I was like, what does this setting do? Oh,
Oh,
it
yeah.
sounds like that. What does this do? Oh, it sounds like that. Oh, this one makes my ears explode. That's great too.
Yeah, it's one of the fun things like with like working with audiovisual stuff is like you poke something or you make even small change and like suddenly does like this cool thing. And it's actually I'm gonna showcase this with Photon Dust because Photon Dust is very easy to write modules for it, and like I've actually written some modules that took me like 5 minutes to write, but then I spent a while just playing around with them, making all kinds of cool effects, and it's like really fun to do those kinds of systems. Also, thank you so much for the subscription, and Nyalov, thank you for the subscription too.
Yeah.
I'm gonna clear this out. Stelnar, what's the most interesting thing you've seen made far with Photon Dust? Let me actually, I'll just bring this in. There was actually kind of cool thing because, or like, whenever we make an update and there's something, there's like visual or audio, there's one member from the like Japanese community, Orange, they always do these like super cool videos. And like when I released Photon Dust testing, I was actually thinking in my head, I wonder what Orange is gonna do with this. It's probably gonna make something cool. And and like not even 24 hours later, he just made like this video that I'm gonna bring. Give me a sec. And I'm like, I was looking forward to this. And then Orange actually organized like an event with the Japanese community where they were just messing around with the new particle system, making cool things. So I have a few that I can show you. So this is the orange one. I'm gonna pull this one in. Let's see, how does it look? I'm gonna click it. There's no sound to it. So this is the thing that Orange did with Photon Dust. And he even specifically mentions in the tweet that like you can have all these particles and the FPS is not really dropping, which we'll get to later. There's another one. This one's also like one of my favorites. This is sort of like a nebula like kind of looking thing. So if I play this one, you can see this is like all particles and they're like moving.
Yeah, it's almost like there's so many. It's almost like a volumetric cloud.
Oh yeah, I mean pretty much is. It's like a nebula thing. Like this one I really like. Like there's a lot of kind of subtle motion. I'm not sure like if it's fully coming through on the stream, but it's very impressive. Oh, there's also this one by Rapids. Is this the right one? I think this should be the right one. This one I also like really liked, so I'm kind of pushing side around with this one. I'm gonna play this one. This is also super cool effect. People have been playing a lot with the turbulent force, which is one of the things I added, because you can make all kinds of really cool visuals with it.
Oh yeah.
Like this is super pretty. Like it kind of makes me happy, to see like people having fun with it and making all these kind of cool visuals.
I think one of the things that I asked you to implement was like having a 3D texture to basically make a vector field for the particles. So like if you make your 3D texture right, you can make a vector field for the particles to flow through in the direction that you want them to go.
Okay. You can make them like do cycles and like loops and like I made like one of the devlog videos like where I was like messing around with it. I was like, this is very weird how they behave, but also kind of fun to play with. So like once it goes on the main build, I expect people to be just having having a field day with it. But yeah, like those videos, like they're super cool, and like to me that's like one of the most exciting parts of development is like just seeing people have fun with the new system and exploring all the things it can do. Sometimes like especially during the testing phase, exploding themselves, and it's just kind of like it makes it feel like like all the work and like put into the system was like really worth it. So yeah, just and I kind of expect to see kind of a lot more. So thank you, Kebis has subscribed as well. Thank you. Granny K is the next question. Granny K is asking, is there any intentions to make importing avatars easier? For example, better head and head detection, Unity package import, etc. Yes, so generally the avatar creator, like it needs an overhaul. And there's like several things on it. The original, it wasn't really designed with like heuristics much. So it's not like, it's not really good at like kind of automatically detecting stuff. It requires more manual steps, and adding heuristics tends to make it kind of worse in some parts. At least like, for the alignment of things. But also it's sort of like, it's one-time process, where like, like you click it and you're done and everything's kind of set up. So my general kind of idea to like rework it is there's like multiple parts to it. One of them is build a new version that's just from the ground up, like built with like good heuristics, so you can actually figure most of the stuff on its own. Where the hands are, where the feet are, where the head is, where the eyes are, and sort of like set it by default. So most of the time you just have to like click a button and like you're done. The other part is instead of making it sort of one-time tool, make it something where you can essentially use it multiple times, like to make adjustments. So you would like turn something to avatar, it does the heuristics to do the initial positioning, but like you can adjust it on the fly, and then you hide the visuals for the adjustment, but then you're like, okay, this avatar, this hand of position feels off, this head position feels off, so you just activate it again. You use whatever handles, whatever UI pieces to make changes you need to make, and and then you hide them again. So at least for part of the process, make it so it can be repeated multiple times, because right now if you want to make adjustments after using it, you need to you essentially need to go to the inspector, and make the changes there. The other part is the Unity package import. That one's a little bit complicated topic, because Unity package, it's a format that's very specific to Unity. So in order for us to fully support it, we would essentially need to implement a lot of Unity, which also is not gonna be usable long term, because if they change anything with a format, now we have to reverse engineer those things again. We could also just extract the FBX or whatever files in the Unity package, but it's also kind of iffy, because the Unity package might have the avatar already fully set up. There's also one approach that I feel would work the best, is introducing actual Unity SDK, because that way you can just import the Unity package into Unity, and then use the SDK to convert that avatar that's already fully in Unity into a Resonite equivalent. You could even make some sort of pipeline with it, where it tries to find the avatar, but you run it from within the Unity. So that's a possible approach there. There's also where the reworking the avatar creator might help, because if we have better heuristics, we can call them on the imported data, so it just kind of sets it up for you, and maybe give it more hints from Unity, so it's able to figure most stuff on its own. Next question. Oh, this one's just a within chat question.
They had a
follow-up
in the chat somewhere. Let me see if I can find it real quick, just by...
Yeah, if you have a follow-up, please make sure there's a question mark.
So Grand UK says, what I mean by a community manager is someone who can act as a kind of filter to accumulate complaints and requests, so that it's easier for the team to know what to focus on. The team leads can still be approached for specific queries, but generic stuff to go through a community manager who's already got connections in the community to get the response of the community and their needs.
So this it's also kind of a shared role right now. There's not a single kind of point of contact. It's oh wait, don't move it.
Oh, sorry, I have the
Oh,
I
I
have
pulled
it,
it
I
out.
have it here.
Okay,
I'll hold it up for you.
I can hold it.
Can you hold it? Does it? Oh, it drops. I thought it was okay. Cool.
Yeah, so we don't have a very specific question, person for this kind of stuff. We do the different people on the team. They will bring up certain kind of complaints and requests and things. They'll kind of bring it during team meetings, and we kind of discuss things. It's something we kind of consider having a very specific person to do it, but us kind of being small team, we tend to share a lot of responsibilities, or spread a lot of responsibilities between multiple people. We've been having people from the marketing team that kind of go around the community, and they kind of relay some of the kind of general kind of feedback and vibes and so on. So we'll see, maybe at some point, but yeah, right now there's not a single person you can kind of go to for everything, and I'm not sure how well it's gonna work as well, because it's there's only so much a single person can kind of handle, so it's they cannot have one-on-one with everyone kind of in the community. Next questions. AK __ 222 is asked, hey, can we import Unity scene to the game? So right now you can't directly. You need to use something in Unity to export it as a GLTF or FBX and import that. However, we do have a Unity SDK on the roadmap. It's on our GitHub. If you'd like to see this happen sooner, I'd recommend giving that issue an upvote. What this would essentially do is give you a tool where you load it up in Unity, and you can convert a Unity scene or Unity object, whatever you have like in Unity, you convert it into a Resonite equivalent. And the way we want to approach this is by making it sort of like a framework for making SDKs. Whereas, like if you're familiar with web browser terminology, they have something called DOM, the Document Object Model. And if you're, like, for example, writing JavaScript, it's a way, for you to manipulate, the page. We would offer something that's kind of similar that you can kind of access over network, and that would represent the Resonite's data model. And it would have, like, an API that's easy to integrate into other solutions. So what would happen is Unity would have, like, part that kind of connects to the Resonite, and it uses that to, like, build out the scene, based on its, on its own scene, and kind of sync it up. The way you want to approach it is, build sort of the base of it where it converts a lot of common Unity stuff, but make it easy for anyone to add additional conversion scripts. So, for example, if you want to convert specific materials or components, or even like kind of more complicated setups, you can add extra code to the SDK to handle conversions, of those bits, and kind of expand it or modify it to your needs. And that way we would, like, we would essentially allow the community to expand this SDK, and, like, if you have very specific components, you can build your own tooling around it. And also, it would allow for other SDKs. So, for example, you can have, Godot in SDK, Unreal SDK, which connects, to the same Resonite, like, same Resonite sort of, DOM, the Document Object Model equivalent, and use that to, manipulate the scene Resonite and, pipe data in and out. Nyalov is asking, can you boost Sire sound? Let me go to my audio settings. Sire, can you say something? Hello?
I'm saying a long sentence, meow, meow, meow,
This
meow,
one too.
meow, bark, woof, squeak.
I can't, unfortunately. Hold on, I need to add a filter because you're right now. You're at, like, at 100%, so I need to add, like, a gain filter. So give me a second.
Oh.
Okay, try talking now.
Hello, I'm
Test 1, 2.
talking.
Okay.
Meow, meow, meow.
Is this better? Let us know if
Hopefully
it's still too quiet, but it seems to be, like, going about the same level. Deathhammer
Wow,
to
it's only 2 minutes.
Syro. Someone wanting. Actually, you want to read that one?
Yeah, I'll read this one. Deathhammer asks, to Syro, as someone wanting to experiment with VR and Linux, what are some pitfalls you ran into when trying to get VR to work with Resonite? So, I actually didn't have a lot of problem making it work with Resonite. So with VR and Linux, a lot of the niceties that have kind of come of it are still kind of like being iterated on quite heavily, and so they're kind of still in like the more bleeding edge distros. Particularly Arch is reaping a lot of the benefits right now, Arch-based distros, especially due to the fact that they have like the AUR and stuff, which is like the user repository. In terms of some of the difficulties, I guess one of the difficulties I experienced recently was that the program that you use to like get up and running, it's called Envision, and what it does is it compiles like a profile for you and builds like Monado and Open Composite and stuff. And Monado is an open source OpenXR runtime, and Open Composite translates OpenXR calls into OpenVR calls, which is why I can use Resonite. The problem with Envision right now is that it doesn't set your GPU to VR mode. So I was experiencing a little bit of like weird, like jitteriness in my headset. But there's actually a website you can go to. I don't remember the link, but if you look up Linux VR Adventures on like Google or whatever search engine you want to use, you should be able to find that website, and they actually have a couple scripts there to set VR mode on or off, which helps a lot and makes it not like jittery anymore. Like it works pretty good. Oh yeah, another one was the eye tracking, because Steam Link doesn't really work on Linux. The eye tracking provided by Wyvern, which is the open source streamer I mentioned earlier, is only provided through OpenXR APIs. So I spent like a weekend or so trying to, like, I basically wrote a driver for it, essentially. It just takes the OpenXR data and transforms it into Steam Link formatted data, which then you can pipe into Resonite. And if you, we should make an option to turn on the Steam Link or the Steam Link driver, like force it on.
Oh, yeah, we
Or
kind of.
some,
Yeah, there's been kind of some
yeah,
issues with that. Like,
yeah. But anyways, those were a couple of my difficulties with the getting it to work. Is like I had to write my own uh like proxy for the face tracking, but it works good, and I'll probably put it on GitHub at some point once I
oh
like
yeah.
clean it up a little bit.
I was about to ask, like that feels like we got kind of shared, like, with the community, like, would help a lot of people as well.
Oh yeah, I will definitely.
Yeah.
I hope
Okay.
that answers your question.
Thank you for answering that one. I mean, it was kind of directed.
Oh yes. Um, why is it that so Dusty Sprinkles asks, oh yeah, why is it that reverb zones seem to only affect non-spatialized audio? And I thought this was kind of weird too. But a lot of a lot of reverb effects that you apply in like, digital audio workstations or like, by using like VSTs or, whatever you want to use for reverb, they're not like physically based. They don't take into account like the environment around you. And so if you were to apply a reverb to spatialized audio, like let's say there's something making noise right here, and you apply that to the audio coming out of it, like the end result of like the spatialization, it's going to mess up the spatialization because the spatialization is a bit more complex than I think most people realize, because it has to calculate the exact difference between how the audio sounds in your left ear versus your right ear, um, so that you can accurately determine where something is in the
Yeah.
scene. And if you apply a reverb on top of that, it's going to mess that up. In some cases, depending on like the effect, it might be fine. But it would probably mess it up.
Like, one of the things, like, it does, like, that's part of, like, the binaural audio is the HRTF, which is, like, header related transfer function. And pretty much what it is, like, it subtly modifies the frequencies of the incoming sound for each ear. Because if you, like, think about it, like, when there's something, on the left and it comes, into this ear, then, like, it's kind of having a direct path. But for this ear, it actually has to go around and through the skull, and that makes it sound subtly different. Or when it comes, from the top, it's kind of like, coming from the top, so it's not going directly into the ear, but it's going, through your skull and through the shape of your ear. And our brains, they're like very finely tuned to pick up on these subtle frequency differences to determine which direction the sound is coming from. It's also like why you can tell that the sound is coming from the top or from the bottom, because if it's coming from the bottom, that's, it's going through different parts of your head, and your ear is also shaped differently from that direction. And all of that is, all of that, our brains pick up on. There's also like other parts that don't mess with the frequency, which is like, I forgot the term for it. I think it was IDP, like it was like like the time difference. So like if something comes from the left, it arrives at the left ear slightly sooner than on the right ear, and it's another thing that our ears pick up on. So that's kind of, very direct kind of sound spatialization, and like the reverb can kind of mess with that. So I think like by default, Steam audio, which we use for spatialization, it just doesn't work with the reverbs. But it also, usually the audio spatialization libraries, they have their own reverb systems, and those systems are more physically modeled. Which means like they actually model, if something like, if a sound bounces, off this carpet, the carpet modifies, the properties of it, and it bounces into the ear. So on top of having, the initial kind of like sound arriving to your ear, you have like, we have primary and secondary and tertiary reflections that kind of happen in the world. And that also actually gives you some idea, about the shape of the room you're in. It gives you some idea, about the structure of it. Because like if you're in a room with a lot of like, soft padding, that sounds very different from a room that has, stone walls. And the spatialization, like with Steam Audio, for example, you can geometrically model the scene and say, these surfaces have these, properties for sound, and it's gonna simulate that. It's actually, the sort of like it's almost like what's the term for it? Not raycasting. Array
It's like
for
path tracing.
it's like path tracing, but instead of visual, it's for audio, and it kind of like gives a lot of spatialization. So like usually you'd want to like use that to have it more physically modeled, so it actually matches what our brains expect.
Yeah, and that isn't
So,
to say that you. Oh, sorry. I wanted to add one last thing on that, if that's okay. That isn't to say that we couldn't have it on like partially unspatialized audio. So like, let's say you had a radio, but you kind of wanted ambient echo. You could have it be like partially unspatialized, and then the unspatialized part, which would be global around the object, could have that little bit of reverb applied to it, especially in the cases of stereo reverb, like zeta reverb. And we definitely should allow partially unspatialized audio to have reverb applied to it once we rework the audio system.
I mean, there's also like another benefit of reworking the system because, like right now with Unity, I don't know how do we do it. Like we have to kind of mess around with it and maybe do some shenanigans to like make it happen. But when we have our own audio system, like I've kind of had a similar thing, like with Photon Dust. Like the Thanos meme of like reality is whatever I make it or whatever I want, and we just kind of do the thing. We can like that's one of the reasons we sometimes rework system is because we can just make them work the way we want. Versus if you're using another system, it's kind of sometimes it gets hard to like make it do certain things because it's not designed for that. Next question, unfortunately, like I don't know the context for this one. AK222 was asking will it work, but I don't know the context. If you have another follow-up question, make sure to include context in your message because we only see the question itself, so we can't answer that. Next one is Kayobikoyoru is asking, what are the plans to improve hiccups when spawning large objects like avatars? So this was another of those complex ones. I mean, generally anything performance is going to be a complex question. One thing that should help a lot, just on its own, is once we make the switch to .NET 9, because part of the hiccup is well, there's also multiple parts to it, but part of it is like the processing time, which on itself is going to be improved by .NET 9. Another part is caused by the garbage collector, because the one that's used in Unity it's very old. Like it's older than I am. It's like from 1988, and it's not been designed, for this kind of use. But unfortunately, Unity is stuck with it. And one of the things it does, particularly when you allocate a lot of memory, it essentially freezes the whole process and does like full collection. Usually, try to do it incrementally, but like when you have sudden memory spike, like it tends to like do those kind of freezes. So that's contributing to some of the hiccups as well. And once we switch to .NET 9, that has much more modern garbage collector with much better performance. That should remove part of the hiccups. The other part is also loading of the assets themselves, because right now for textures, when textures are being loaded, we use time slicing. What that means is the upload of the texture to the GPU, we only spend certain amount of time per frame to do it. So like it doesn't cause like hiccups. So like if you're uploading a big texture, it's gonna happen over several frames, and the impact of it's kind of spread out. But right now it doesn't happen for meshes. When the Unity integration gets reworked, that's a part that I would like to touch, where the upload of meshes is also kind of like time sliced. Still have to kind of export like available APIs and how complex that is, but that could also help. And if that doesn't happen, or it doesn't help us much, once we switch to our custom learning engine, which is currently called name Sauce, we will have much more control on how data is uploaded to the GPU, because with Unity there's like certain kind of limitations on that, and we actually, even for the textures, we're doing a bit of a hack that Unity kind of makes harder to do. once we kind of have like full control over the engine, like that's gonna give us a lot more kind of options in the regard to make things more, time sliced or asynchronous. So there's like multiple things to it, but like overall, like there should be like also gradual improvements on those. Next question is Stellar is asking, was there a reason for swapping to .NET 9 relatively early in its release? I would kind of flip it. Like it's more like there was not a reason not to do it. The swap was it was literally just flipping, to .NET 9, from .NET 8 to .NET 9 in the project build file, and everything pretty much worked. There was like one syntax like issue that I had to fix, which was one of the functions, and this was in the cloud, it wasn't even on the client, where function was somewhat ambiguous because there was an overload. I fixed that, it compiled, and everything just kind of works. And on the cloud, we actually got bonus performance. Let me actually bring the graphs. I posted them in devlog like a while back. Well, actually, the question is, can I find them quickly enough? I'm just gonna scroll through.
It is kind of cool how even like the incremental upgrades still give you like a nice like chunk of performance benefits.
Yeah. It's literally we don't change anything with the code. We literally change a number and suddenly free performance. So this one, this is our cloud background worker, which generally has like a constant CPU load. And if you look, this is when we switch that worker from .NET 8 to .NET 9, and you see the CPU usage just kind of dropped all of a sudden, which is literally free performance. Every year they release a new version of .NET. They have so many performance improvements. Like if you look at the blog posts, like they're ridiculously long. And like I remember, I think it was like with .NET 7, like the post was so long. If you loaded it on a mobile web browser, it would like crash because it's just too much. And the author of those posts, like they're kind of doing it partly on purpose because originally when they started doing those posts, they were like, oh, like we're getting so many performance improvements early on. The next one, I'm like, we're gonna do them all, and then I'll have nothing to write about. But instead, every year they have like more and more and more to write about. So like, we've been like very happy with this. But also sad because we were not able to get those performance improvements because it requires a huge amount of work. But thanks to everybody in the survey like voting for performance, we're kind of like this is gonna be a big chunk of work, but like we're gonna do it. We're gonna get those big improvements. This is This is the API front-end one. So you can also see like the switch happened around here. And you see like this one has a little bit more variable usage because it depends like on the, how much stuff is happening. But you can see like overall it actually dropped afterwards as well.
Yeah, it's absolutely insane, especially because like the headless, the sheer like Grand Canyon cliff between like the performance between like the headless and the graphical client now.
Oh yeah, like
the headless can render everyone, in
yeah,
like a 40-person session, and it's a 60.
That's the crazy thing. It's like the graphs I just showed, that was going from .NET 8 to .NET 9, which is a relatively small improvement, but it's still like it's still enough that it shows up. There's just more performance. But the one we're using right now, Mono, that's like at least order of magnitude. Like if it was on a graph, Mono would be somewhere here, and then like .NET 9 is somewhere here. Like that's much more drastic performance improvement between the two.
Like half a decade.
Yeah, like it's insane, and that's one of the reasons like we don't want to do it. It's also like why we did like the headless first, so we can kind of see how much it actually gives, because the headless runs majority of Froox engine. Like it runs the same code that's running right now to like do all this, except the rendering parts and few extra bits, but majority of the CPU time is spent in the same code, so it gives us a really good idea like on what kind of performance boost we get.
Yeah, and it was more than we could have imagined. No, go ahead. It's fine.
Next one is actually also for you. Do you want to read this one?
Yeah, I'll read this one.
Oh, this one's...
Naya Love asks, Cyro, is the driver you made for using your face tracking Resonite, they're asking if it's available somewhere. We'll maybe try it next time. I try Linux on my Void, is that Void Linux? also when OpenXR support Froox. To answer the first part, I will most likely put it on my GitHub. I just need to clean it up and not hyper focus on funny little bits of it that don't matter. But it will be on my GitHub at some point.
So to answer like the second one, so OpenXR support right now is actually a little bit difficult because the version of Unity we use doesn't really support it, and the ones that do, they actually break some of the stuff we use. So if we were to do that, like we would have to break, some content, unfortunately, which is one of the reasons we're like, there's like many reasons, but this is one of the reasons we're moving away from Unity to our custom rendering engine, so we actually have control of it and we can use modern runtimes and also maintain long-term content compatibility. So it's not gonna happen. I can tell you it's pretty much not gonna happen with Unity, but like once we switch, to Source, like it might even be like out of the box kind of support. Like I'm not 100% up to date like on that part, but that one will make it at very least it's gonna make it much easier to support it, and I think it's probably gonna support it out of box.
There's a really big asterisk technically with that, and that's technically if you're using Linux like I'm using right now, Monado and Open Composite will actually translate OpenXR calls into OpenVR calls. So I'm actually using OpenXR right now, and it's still faster than Steam VR.
Yeah. So I'm just gonna try to get through the questions because we're coming up on an hour. So I do wanna do the Photon Dust, kind of talk a little bit more there and do a showcase. So next one, we're gonna we're gonna do the showcase. We're gonna cut off we're gonna try to get through the questions we have right now. Then we're gonna have a look at Photon Dust. I want to talk a little bit more about it, like in general, and then if we have a time, we can come up with more questions. So next, Grand UK. I feel a community volunteer could fit well for a community manager to be the community voice in those meetings, where appropriate. Also, if one person can manage the much connection, a team similar to moderation or mentors could be as good as volunteer basis as well to prevent massive workload and less involved in team. What are your thoughts on the idea? So there's few problems with that. One is like we generally cannot do community volunteers on that kind of level because a bunch of company and legal stuff. The other problem I have with that is it's like it makes it one person. In general, we try to avoid having one person for this thing because that introduces more bias into things. So if you actually have multiple people in the team, each providing kind of different perspectives, I feel that's much healthier overall. We do similar things, with the moderation team, where if there's anytime there's a moderation tickets, multiple moderators see it and multiple actually kind of contribute to it, even if there's one kind of moderator handling that particular ticket. And what that does is make sure no particular moderator, if anybody has bias to the situation, there's multiple people kind of checking up on each other. So I feel it's kind of better, something that kind of comes from multiple sources and multiple viewpoints rather than, a single kind of question. The mentors could potentially help. One of the things mentors could potentially do is, make if there's lots of common problems that people are hitting, is for example write up GitHub issues, make reports about it, and we can then look through those. So that's one way to kind of help with those things, but it kind of depends, what do you imagine the interaction to kind of be like. Next questions, Nyalov. Are you planning to do the IK rework right after performance update is considered finished, or is it not set in stone yet stuff? It's not set in stone. The IK is still one of the kind of high things we want to rework. It's kind of up there with stuff like UI and so on. So we'll see, we'll cross that bridge when we get to it. Usually when we finish kind of big chunk of work, we kind of reevaluate and we're okay, where we're at, what's the biggest pain point right now, what's the most, what is the thing that's going to have the most impact that we can work on right now. And it can very well be, the IK, but it could also, maybe it could be UI, there might be also like some smaller projects, because one of them that we're considering is doing stuff like the Unity SDK, because that one's much quicker to do, and we can then let the community expand and build around it. So that might kind of help, but it's not set in stone yet. There's like a bunch of kind of like ideas on that one, and we'll see. Next one is Dusty Sprinkles. When we have multiprocess and Froox engines out from Unity, would upgrading Unity be easier, or would there still risk breaking existing content? Unfortunately, it doesn't make upgrading Unity any easier. The problems we have with it right now that would break content are purely on the rendering side and like what is supported. So we're very likely not gonna upgrade Unity. We wouldn't probably get super many benefits like from it. We're just gonna go for a switch to our custom rendering engine at that point. Next one is Garnier. When you start OpenXR work, make sure to get search or do some testing on Linux to make sure it doesn't break massively there. Yeah, I figure you're probably gonna be like doing a bunch of like Linux testing since you like daily drive it.
Yeah.
Also, next one, Granuke, do you mind if I talk to you in Resonite after a stream, talk over it before I make official feature request? Probably not after the stream. I generally tend to like, go out of like kind of work mode and kind of like just hang out and so on. So I like in general, like I will not want to do like much kind of work talk like while I'm on Resonite, because it makes it much harder to sort of like, set boundaries. And it's something like that's been kind of contributing to like, burnout issues and stuff like that. So like I need to set a hard line there. I'm sorry. I'd recommend just, making the request. We look at it, whenever we can, and we either say like, yes, no, or maybe something different.
As a good rule of thumb, it's best to like take the issues that you're having with Resonite and majorly keep them on stuff like the GitHub, because when we come in game, we kind of just want to exist in the thing like that we made, and we kind of want to just live in it like you guys, and being reminded of like work all the time is kind of hard on the old psyche.
It's already like difficult to kind of like get like out of the work mode like a lot of the times, and the other problem with that is like I used to do it a lot, like when I kind of talked about this stuff like in game, and I even I used to like take feature requests in game and just kind of write them down as people were doing them and do them, but like as the community kept growing, it became like unmanageable, and the problem is if we make exception for this person, then then this person gets upset because like we told that person no, and it just becomes this kind of slippery slope kind of thing that like makes it hard to like set boundaries for things, and makes it harder to like be able to like relax. So we generally like we want to be pretty strict about people going through the official sources. With that, like that's we have like 1 hour minus 3 minutes left, so there should be like time for like more questions probably, but right now I want to do a bit of a showcase and talk about Photon Dust, which is our new particle system. So I'm gonna get this one. It's the one I get up to because we're also gonna be moving over there. So I'm just gonna, there we go, and kind of the floor. There we go. So I'm gonna switch the camera over here. And I forgot my brush. Where's my brush? Oh wait, I'm dumb. I have it on my tool shelf.
I'll grab the chat too.
There we go. So, okay. And where's my streaming window? Where's my streaming window? Oh, it's in the desk. There we go. There we go. Hello. So just to kind of like give it, give a little bit of a context. Photon Dust, it's our brand new particle system that's written in-house. It's written from scratch, and it replaces the legacy particle system that was a hybrid between our system and Unity, which was doing majority of the simulation. Currently, at the time of this video, it's still in pre-release testing, but it's going to be released into main builds very soon. And you can already kind of play with it. People have been doing lots of cool things with the system. And we're gonna just kind of showcase you, how is it built. And one of the reasons we also did Photon Dust is because of the performance updates, but also to kind of get more control on the particle system works, and how is it kind of put be able to add a lot of new features and a lot of tools for people to work with. And I'm actually gonna do a little primer on particle systems, because if you think about it, particle systems at their very core, they're very simple. So say you have a coordinate system. I'm just gonna do 2D one. What particle system is you have a bunch of particles. Each particle can have a position. So this one has position on the x and y axes. I need to label my axes. So there's position. You have the position. You might have rotation. The particle might be 2D, it might be 3D rotation. It can also have stuff like size, and something like color. And there can have stuff like velocity. So for example, it has this velocity, which means it's going to be moving this way. So they can be velocity. And then you have a bunch of particles in the system. Maybe there's another one there that has this velocity. And there's a whole bunch of particles in a coordinate system. And what you do is you update the simulation based, for example, on their velocity. So if you advance it in time, this particle will move over here, and this will move over here. And it's going to happen for every single particle in the system. You can also, evolve their size or color or rotation. They can, change over time, or they can change based on, some equation. And then the other part is when you have the simulation, the particles, they're essentially just pieces of information, like the position, size. I didn't add the rotation, I just got to add the rotation here. Position, size, color, velocity, which is used internally. And then you render it out, which means, for each particle, for example, you can get a sprite that you render around this point in space, or maybe, a little 3D model or whatever you want. And then, the sprite is colored, by the particle's color. So that's kind of gist, of how particle systems work, is you have points in space, and you're updating their parameters over time. They also have something called lifetime. And essentially that indicates how long does the particle live for. So when it starts, maybe the lifetime is 1 second. So it keeps moving, and each step its lifetime is dropping. So here it would be say it's 1 second here, and this is 0.9 seconds, and over here it's gonna be 0.5 seconds, and then after 5 seconds it's gonna disappear. The lifetime is also something that you can use to drive other parameters. So for example, say you want the particle, to fade in and out. So what you're gonna do is you're gonna define, some kind of function. How does the color of the particle change over its lifetime? And you can essentially say at the beginning of its lifetime, if you were, say this is, alpha. And this is, when the particle starts living. This is when it dies. That's 0.1 seconds. And you're going to say, the particle, you make a function that's when the particle starts living, it goes, from transparent, it becomes visible, then it kind of exists, and then sometime, before it dies, it's going to fade out. So that's, for example, one way, to map its lifetime to a property like the alpha or color. It could also be size, it could, start tiny and kind of, and then kind of, get big and then get small again. You can also do multiple parameters. So for example, you can do alpha like this, so it actually fades in and then fades out, but also you could do something like size over time, where it just keeps growing. So it can start, at certain size, and it just keeps growing. And it dies, at certain size. And you have created mapping between the lifetime and the size of the particle. there's lots of different ways, to create mappings between these properties in order to create all kinds of effect. Like if you think about it, for example, like a smoke effect. So you have you have a sprite that's a smoke. It's some kind of smoke sprite. And for each particle, it fades in when it appears. It doesn't just, pop into existence. It stays, and then it fades out. And you also combine it with the size, so it starts small and it kind of expands. And as a way, you can combine two effects, to get like a smoke effect or lots of different ones. You can also do, lots of other effects. For example, you can have, you can apply forces to them, like turbulent force. So instead of the velocity of the particle just being the same, let me actually do another one over here. So let's say one starts here, and the particle starts moving this way, but maybe, there's a force that when it moves over here, the force now moves here, which means next time it's going to be here and the force rotates this way. And next time it's going to be here and the force rotates this way. And it makes the particle now follow, some kind of turbulent path because the velocity itself is changing over time. So there's lots of things like that you can do, with the particle system. I'm going to clear this out. The way photon dust is designed is you have some base properties. So you have you have the position, you have rotation, you have scale, and you have color, and then you have also lifetime, which is how much lifetime it has overall. Lifetime. So those are some of the kind of built-in properties that particles have. And these, every single particle is always gonna have. Some of them can be just, default, but they are kind of part of photon dust. And there's starting versions of these. When the particle is first created, when it's essentially emitted from an emitter, it initializes the starting values. So for example, the emitter can, it gives the particle position. So if you have a sphere emitter, that's emitting particles, it can be emitting, particles within its volume. It will give each particle a position within that volume. And it's, the job of the emitter to do that. You can have rotation, scale, color, they are kind of initialized. And for example, for color, you can have a module, and I'm kind of skipping ahead a little bit, or just kind of back a little bit. The way photon dust works is you have these basic parameters, and you have a set of modules. And modules that can do multiple things. Some of them will initialize the starting properties. Some of them will calculate new properties during the particle's lifetime, and some will kind of, do a mix of both and do more complex stuff. So you have modules which initialize some of the properties. So for example, you want each particle to start with a unique color. You can have a module that computes color for any new particle. There's a mix between two different colors. Or maybe it picks it from a texture, or maybe it does some equation to compute it. Or maybe, sometimes the emitter can, also contribute a color if it's a mesh emitter. Or if it's an emitter with just some, equation to compute the initial color for the particle. What photon dust does is it has, a bunch of these starting properties, but it also has sort of output properties. And for those, you also have position, you have rotation, you have scale or size, and you have color. And there's also another one, I'm not gonna, I added here, which is a frame index. You can think of it as sort of UV coordinate. You don't have to worry about this one super much. These are really the main ones, because this is what is needed to render the particle. You're essentially going to render the particle at certain position in space. You're going to render it with certain orientation, at certain size. The size is 3D, by the way, and with certain color. And these then go into a render module. So this goes into a renderer. And the renderer is essentially responsible for taking this data and making the particle appear in some way. And it can be like a billboard, so it's like a billboard sprite. So there's like there's specifically a module called billboard renderer. There's also like a mesh renderer, which for each point is gonna render some kind of mesh. And there could be like more in the future. Like one that I kind of want to add at some point is one that actually computes a mesh using something like marching cubes to sort of create like a a surface. So you can do stuff like that looks like liquid. And there's like kind of lots of like opportunities like for additional renders there. But the gist of it, they take these, they make sure it's rendered out. And then the Photon Dust itself, it will take stuff like the emitters to add new particles to the system, and then we have a bunch of modules which take these and compute these. One of the important modules is the position simulator, and this is a typical way particles are simulated. But unlike the particle system that's in Unity, Photon Dust is very modular. So there's like, there's lots of different ways the initial properties can be transformed into these output, like render properties. But just to kind of keep things simple, you have the position module. So I'm gonna just be position module. And the position module, what it actually has, you can notice like, in the starting properties, like you don't really have, you don't have the velocity. And it's because there's lots of different ways to compute position, and the velocity is specific to the position simulator module. So the module can actually add its own internal buffer, which is velocity. And that velocity can also be initialized from starting properties. You can have like module that, for example, assigns a new speed that's like, between minimum and maximum. There's also like one initial property that I omitted called direction, or sort of like initial like vector. So the position module, when a new particle is added, it will take the direction to compute initial velocity, and that will then get multiplied by any initializer module to kind of like, compute the initial velocity. What the position module will then do, that every single update, it will essentially compute a new position for the particle, and it makes the particle move around. And you can have, another module like, color over lifetime. I'm just gonna go color lifetime. And what this module does, it will take the starting color and it'll do something with it, like it's gonna multiply with some value, and then it, computes the output color. And it can do whatever math it wants in here. You can also chain those modules. So like if you have multiple modules, so you can have like, one, and there's like, another one that like simulates color in a different way, or maybe just does, does the alpha channel. And if you have multiple of them, it'll take whatever is computed, do whatever own math, and then, assign the color. It's sort of like a chain. Which is like why for Photon Dust, the order of modules matters. The same also happens for initializers. If you have something that computes the starting color, it's gonna, if you have multiple of them, they're all gonna contribute, and their contributions are multiplied with each other. So this is the kind of general gist, of how Photon Dust works. Is we have some starting properties, we have some sort of like lifetime kind of properties, for example, lifetime. I kind of simplify this one a bit because there's actually there's a starting lifetime, which is just how long the particle is supposed to live, and then there's like its current lifetime, which is how much it has left to live. And some of these properties change during the lifetime. Some of these are specifically starting ones, and the ones that end up changing are like these. So this kind of should cover. This should kind of cover like kind of the basics. You have like the starting properties, you have some lifetime properties. Modules modify these in various ways or initialize these. It computes final properties, and then those go into a renderer that like shows the output in some way. I'm actually gonna do a showcase, and I'm gonna switch this one to first person camera. Oh, and you can see my hair. Give me a second. Wrong one. There we go. So you should have the Froox view now. And you can see Sarah over there. And I'm gonna spawn a developer tool from the inventory from Resonite Essentials. So this is the developer tool for anyone who's not familiar with, and I can start creating. So if I go open context menu, there's create new, and you see there's the legacy particle system. During testing, both systems are available. And if I spawn this one, you see, this isn't called legacy particle style, it's just to kind of give people idea this is gonna go away. But this old system is very monolithic. You know, everything like is kinda bunched up in one place, which makes it a little bit kind of hard to work with. It's also like hard to extend because, for example, the size of the particles is initialized, you know, it's always min and max, and makes it harder to do lots of different methods to, you know, initialize those. I'm gonna get rid of this one, and instead I will create a new particle system. So this one's gonna be Photon Dust. And you see over here, you have the particle system. That's the actual handler of the simulation. So this is like, you know, what's triggering all the simulation with particles. But in order to simulate them, it uses a particle style. Particle style, it defines, you know, how the particle system behaves and how it looks. Each particle style is going to have specifically a renderer, and you can see it actually says billboard particle renderer, which is, you know, what I talked about. Oh, why cannot I? Oh, my controller was weird, sorry. Which is essentially what I was talking about here. And that's responsible for rendering these particles, you know, in the world. There's also a number of modules, and initialized it with a few basic modules, so, you know, just to give it some initial behavior. And you can see, you know, there's a few of them. And the modules are the ones that actually do stuff in the particle system. You see there's the position simulator module. If I actually make it go away, you see now it's emitting particles, but they're not moving around because there's nothing that would be moving them, so they stay at their starting position. So I'm just gonna undo that. Then you see the sunlight burst out. There's also a bunch of stuff that's been kind of organized here. So a lot of these modules, they've been put under these slots. It's not necessary to put them there. I made it this way just so it's kind of easier, so you don't have like, you know, a million things in one place. So I can be, you know, this is the emitter, this is where the particles come from. And, you know, if I move it around, it changes where the particles come from. I can change the rate of emission. I can be like, you know, add more there, add 1,000. You know, and I have a bunch of particles here. Ooh. I can change the color for this one, for example. This is like a new thing somebody like mentioned. I just made it part of this emitter. And when I'm changing this is actually the emitter itself, which is giving the particle its starting color. But you see, it's still being kind of combined because the particles, when they were white, you see they go from white to black. And the reason they do that is because of the initializers. There's specifically color range initializer. And what this does, it picks a random color between minimum and maximum value. So if I change this one, you see they're now getting a random color that's a linear interpolation between these two. And this doesn't depend on the emitter at all. That's the module giving them, you know, that value. I'm gonna change this one back to black. It is being combined. Not all emitters have this. The point emitter has, you know, a single color. So if you assign it, it multiplies the color, which means they still go from fully bright to black, because that color by the initializer is being combined with the emitter color. I can also add other emitters, so I'm gonna actually get rid of this one, and you can see like it stops emitting because now there's nothing that's introducing new particles into the system. If I go under rendering, particle system, emitters, there's a whole number of them, and I'm gonna use box emitter because that one has like a bunch more color options. So for each emitter, you need to assign it the system that it's adding particles to. So I'm gonna open this one next to this, and I'm gonna take reference to this and drop it here. And you see, now it starts emitting new particles. And I'm gonna increase it a bit. I'm gonna do 1,000. And you see now instead of emitting from a single point, the particles are actually emitting from a box volume. It's a little bit hard to see, so I want to slow them down. So I'm gonna go back to the initializers. And there's a speed range initializer. So I'm just gonna drop it to lower values so they don't go too fast. And you see, like, you can better see the box shape of them. What you can also see, if I go back to the emitter, this one has its own method, to give them initial colors. So I can, for example, color each vertex of the emitter. So I can make this one red, and I'll make this one blue, and this one green. I think that's not quite enough particles. I want a bit more. So what I'll do on the particle system, you also have a limit. You see, like, we're actually reaching how many particles the system can have. So let's just add extra 0 there. There we go. We can get more particles. And let's see how many we have. We have about 3,000. We can bump it up a bit more. Let's do like 5,000. There we go. And now it's going. Now it's going. I might actually, some of them like live a little bit too long, so what I'll do, go back to the initializers, and there's, lifetime range initializer, and I'll just set it so like they live 1 second, because right now they were living between 1 and 5 seconds. So that now they don't, live too long. And so we can kind of get, a kind of box shape. And it's kind of volumetric, so if I go inside, it's full of particles. Each of the emitters, they have a bunch of properties, so you can kind of control how they move. I can, for example, say this one to emit from shell. So now instead of, being emitted from the entire volume, it's sort of like, a shell of a cube. And they're still kind of being colored. So what you have in this case is you have the emitter, and you can have multiple of these, which is adding new particles to the system. The emitter can also provide some of the starting properties, like the color in this case, and the direction. And then you have initializers, which modify the starting properties. For example, the color range initializer takes, the color from emitter, it multiplies with additional color. The size is initialized, the particles are different sizes. The speed is initialized, lifetime is initialized to something. And then you have simulators. And the simulators, they are what is responsible, for updating the particles over the lifetime. And right now there's only the position simulator module. That's what makes the particles, move, because each update, it computes their new position based on the velocity, on their velocity. It has a few properties on itself. It can, for example, do collisions. So if I enable that, you can actually see an interesting effect here, because now all of the particles are computing collisions. And what you see is, we might need a bigger collider, like a box or something. What you see though is it's running at a lower frame rate, but it's actually the particle system itself is running at a lower frame rate than I am. So if I switch this here, you see I can still move at a faster rate than the particle system is updating on. And this is one of the big improvements that Photon Dust has over the previous particle system, is it's asynchronous. If you make the simulation too heavy, which is in case of having too many particles, I'll actually make some modifications so we can see the collisions better in a sec. If you make the simulation too heavy, instead of this being your frame rate, instead of us running at the frame rate of this particle system, it's only the particle system that runs at a slower rate. All of the simulation, it happens on multiple cores, so this is gonna, is multi-threaded, which the previous system was mostly as well, but it's also specifically asynchronous. Let me modify the properties a little bit. So like I would actually want the particles, let's make them fall to the floor. For that, we actually want something that's gonna update the velocity. So I'm gonna add a gravity module. So I'm gonna add attach component. Because when you think about it, like what gravity is it's modifying the velocity every frame. Like if the particle starts moving, this way, let's see, where did I leave my brush? If the particle has some velocity, gravity is a force that's modifying that velocity, is essentially acceleration that's pulling it down. So as the particle, it moves over here, and the direction moves a little bit downwards. And then like it moves over here, and the direction moves more downwards. And then moves over here, and direction more downwards. And then moves here, and direction's now almost aligned. And essentially then ends up like, falling. It's because like there's a force that's being applied to the velocity that's, making it move downwards. And it's also accelerating because it's an additive force. So every update, the velocity is higher and higher and higher, which means it moves faster and faster. So if I go to rendering, particle system, modules, these are probably gonna get more organized after like some time in the release. But I'm just gonna add the gravity force. And then what I need to do is I need to open the system itself. When you add a module, each module can be shared between multiple particle systems. So you need to be able to tell the particle style that you want it to use this module. So what I'll do, I'll just add a new empty space for here under the modules list, and I'll drop it here. And the particles start falling down. And now do we have a nice collider? Just put it in. Make it a little bit bigger. I might need to have them live for a bit longer because this is a little bit harder to see, and make them a little bit less dense. So I'll do this. This one is particularly bad like on collisions. So there's just this many, and I'm gonna make them live, say for like 4 seconds. There we go. And you should be able to see they should be like rolling off. Wow, this word is really bad for collisions. I think it's because there's like a lot of colliders and stuff in here.
Does this query any Beppu structures?
Yes.
Okay.
Yeah, all the collisions that's against Beppu because this is the physics engine we use. I'm gonna make this smaller so it's a little bit easier to so it's easier to see. Let me also reset the colors so it's I should have been doing, hold on, let me just drop this here, just so it's kind of nicer to see. There we go. And you see they're kind of like, colliding and flowing there. And if I go back to the simulator and disable the collisions, they will start falling through. And you see that runs a fair bit faster, but now it's not colliding anymore. But that's one of the benefits is like, if you had like worlds that are particularly not friendly, to collisions, this would like, if this was the old system, this would be killing our frame rate. But we can still kind of run, and it's just, it's only the particle system itself that degrades. Let me lower this a little bit more. I'm just gonna do 100. So if it's fewer of them, it has like fewer to simulate. You see like it actually starts running faster as they kind of bounce around. I didn't expect this war to be this bad for collisions. It's actually one of the things that I kind of also expect that we're gonna get like a significant improvement on once we do the switch to .NET 9, because Beppu Physics is specifically optimized, for modern .NET, and it's running way slower than it can, with the mono. We even had to do some things to make it run reasonably fast, But like we're not anywhere like tapping its full potential. So like there's gonna be one of those things that's gonna be interesting once we make the switch and we're actually running video.9. I kind of expect the simulation to happen a lot faster when there's lots of physics, physics interactions, but also in general because it just generates way faster code. But you can kind of see the particle system, how it's kind of doing its work. If I switch back here, I can show you some more modules that I can do. So one of the things, I'll change the initializer. I don't want to be that dark. I just want to be a little bit. There we go. Another bouncing over here. There's lots of new effects that were not possible to do before with the old particle system, and ones that particularly benefit from the modular nature of the system. So I have added a module that simulates the force, which essentially just modifying the velocity. Let's add one that modifies the color. So I'm gonna do attach component, rendering, and I'm gonna do modules. This one's my favorite because it makes cool visuals, is color HSV over lifetime start end. So there's lots of modules, that will modify the color somehow. But I particularly want this one, because what this does, it changes the color of the particle based on how long it has lived. And it changes it in the hue, saturation, and value color space. Which means if it starts at 0 hue and ends with 1 hue, it goes through the entire color spectrum. So I have added this module. Now I just need to add it to the particle style. So I'm gonna take this, I'm gonna drop it here, and whoop, and you see it immediately starts coloring the particles. I kind of like this effect. It looks pretty.
It's like Skittles.
Skittles. You could even do things if I set it to 2, then it's actually gonna cycle. Making them go all around. It's actually gonna go through the hue twice. So you see it starts red, gets to red in the middle, and then goes through the spectrum again. So you can play with these properties. You can also just have it go through just part of the spectrum. So this one just gets from red all the way to green. The important part is also what this module is doing. If you look, I'm gonna position this. This might be actually a fair bit distracting, so I'll move it. I'll move the emitter from here. Where do I move it?
Can we make them have shadows?
You can with the right renderer. I'm just gonna move it over here. Have them bounce over there. There we go. Or maybe here. Now they're going on the desk. So what this module is doing, and I have a bunch of clutter here. And I lost my brush. Oh, there it is. What the module is doing, it's taking the starting color, which is initialized by the initializers, and then it's computing, it's taking the current lifetime, seeing how long the particle has lived, and it computes a new color based on that lifetime, multiplies it with a starting color, and then writes it into the color to be rendered. And that's kind of how it's achieving its work. You can also combine multiple things. I actually have a request, Sarah. Would you be able to bring me a gradient texture, whatever gradient texture you would like?
Yes, I do have one actually.
Do you have a cool one?
I do have a cool one. Let me see if I can find it here just real quick. Aha, here we go. Here's all of the colors of the rainbow.
Beautiful. So, where's the colors of the spectrum? Which is that's pretty much rainbow. So what I can do, I'm gonna switch this back into smooth POV. What I can do here is add another module. I'm gonna add another simulator, and if I go here, I'll add rendering, particle system, modules. There's also color over lifetime texture. And what this module does it assigns it instead of like, you know, the color being computed mathematically, it will read it from the texture, you know, going from left to right. One thing I need to do in order to use this texture, I need to make sure it is readable. So I'm gonna open it in Inspector. Let's see where the texture itself is. I could have just opened from there. I'm just gonna open it here, so I'll grab this one. Get rid of this. Oh, this is a procedural texture. Okay. I thought it was a big one. So this one's already gonna be readable because procedural textures are readable by default. Yeah, so I can literally just grab this texture and drop it here. And I'm gonna open, I should have probably just kept this. Oh, no, I have it open over there, so I'll just grab this. Let me just pull this out. So I have the particle style. And I'm actually gonna replace the module first. So I'll put this one here. And you'll see it's actually, as the particles live, the colors are going, you know, through the values in this texture. So you can add, like, you know, whatever you want there. Like, I could literally even do this, you know. This is probably gonna be weird, but I could take a picture once it loads and drop that in there, and it's gonna, you know, it's gonna use those values to color those particles. This one I do need to make sure it's readable. So I need to check readable. I need to check uncompressed. There we go. Now I can drop this here. It's only gonna use like a strip of it, so it's gonna be a bit weird, but you can kind of see, you know, it's getting the colors from this texture.
Oh yeah, it's like just going along the top.
It's going along the top. I do want to add a module that like lets you kind of like, you know, randomize like which part of this also kind of comes through. So there's gonna be more options for that, but you can see kind of in action. But I'm gonna drop this back in. And actually I have like another request. Can you find a texture that's also like a gradient, which is a color gradient, but it doesn't go through all the colors. It's only a few colors. Find me that one. And I'll show you like another effect, which comes, you know, with combining the modules. So this module, each one essentially is like, you know, doing something to the colors. If I take this one and I also add it, you can see it doesn't quite like look like much, because now the colors are getting multiplied with each other. So what I'll do here is instead of changing the hue, I want to keep the hue the same. So now it's actually starting like, you know, it's literally just the red hue for the whole lifetime, and it gets multiplied with the hue on this one, and because it's red, any other color gets masked out. But what I can do is I can also remove the saturation, because I don't want it to be like, you know, kind of saturated at all. And now I can change the values. I can, for example, set a start value to be black, and you see like it's kind of combining the contributions of these two to produce the final color. But what also matters is, you know, which order these modules are in. So if I swap them, well, actually for this one it's not gonna matter, because the multiplication is always the same. In some cases it'll like matter, because depending, you know, on the order of operations, that's gonna produce you different results, but in the case it doesn't, because it's a multiplication. But you can kind of, you know, you can stack multiple different modules to like, you know, produce behaviors. As I'm checking on the time, I'm actually gonna speed this up a little bit, because yeah. So I would like skip over the other texture stuff, because there's a few more things I wanted to showcase. One of them is, you know, some of that kind of turbulent stuff, because those are really cool effects. And I see we have a few questions as well, so I'll try to get those in a sec. Let's switch this back to the camera. And I'm gonna bring the emitter over here. And I will remove one of these systems. I think I've closed it. I always close things without thinking about it. So get rid of this one. I'll change this. Simulators. I'll change this one to have the full saturation.
I couldn't find the color one, but I can.
No, it's okay. Like I'm gonna skip that part right now, because
okay.
we're kind of running short on time. And also I'll get rid of the collisions. Then I will lower the gravity. I don't want it to be that strong. There we go. So one of the cool effects, maybe kind of going like this. One of the cool effects also, there's a new turbulent force. So you have the gravity force, but we can also add under rendering particle system modules, there's a turbulent force. Oh, actually, I think it's called simplex turbulent force. There we go. So I add that one. I will add this module, simplex turbulent force. And you see it kind of starts, the particles start kind of like, flowing a bit different. And you can like, mess with these settings, there's like different ways for it to work. So like, you can, for example, have it like, alter direction. And see now the particles are going, doing this thing, and maybe you can make it stronger. And maybe I want it to be like, do like this kind of thing. And maybe increase the scale, so like it's a little bit more, kind of varied, and this one actually might be too strong for this. So you see now they're kind of like doing like this kind of more complex behavior. I'm not gonna like mess with it too much because like there's like you can literally spend hours like just messing around with this, producing all kinds of cool effects. But you see the particles like they can do a lot of kind of cool stuff. There's like one more thing I'm gonna actually show you because I want to give a little bit more kind of background on how it works. Like each particle it can have. It has its own render, but there's also specific modules which are also their own renders, and they add like additional rendering to the particle system. One of those is the trails module. So if I go back to smooth POV, I'm just gonna add it to the root. Rendering, particle system, modules, there's the trail. Trails module, where is it? Trails, particle, it's particle trails module. There's particle lights module, ribbons, trails. I'm gonna show you the trails one. So there's the trails module, which has also a bunch of stuff. I'm gonna just give it the same material for the time being. There's lots of options to play with, and we don't really have time to like go through all of these. But I'll assign it here. And now you see the particles actually start drawing trails. Which is like, looks really neat. And if I now start like, messing with like stuff like the forces, I'm gonna go simulators. Gonna make them, stronger. Oh, this is weird. This is just turned into a clump. And change the scaling on it, on the turbulent force. There we go, you see now it's doing all these cool things. If I change the force offset, it's gonna do like... Oh, that is weird. You need to mess around with it a fair bit. Might need to like lower the strength, so they're not like too constrained. Or do this kind of thing. Oh, that is neat. Yeah, I'm kind of getting into the... There we go. This one's supposed to go this way, and I'll change this one. There's lots of different things you can kind of, do. Like, you can just mess around with it and do all kinds of effects. But what I wanted to show you with this one, there's also, like, modules where... There's modules where... Actually, sorry, can you move them a little bit somewhere? So they're not in the way. I'm just gonna clean up. I think I kind of showcased like enough. There's like, I underestimated how long this is gonna take, so I do wanna get like to some questions. Okay, they are over there now. It's fine. Oh, they're going a little bit over here still, but it's fine. It's fine. So there's also like modules, which kind of act after the main modules do. So like there's a trails module. Trails, And what this module does, this is something called internally a follower module. And there's a few of these. And what it does, for each particle, the particles can be followed by additional effect. In this case, a trail. And what it will do, it will essentially look at the final simulated position, and it has its own internal data. There's like the trail data. I'm not gonna go super into details on this one because there's also like a rabbit hole. But it'll trail data. It'll take, the color, it'll take the position, it'll combine it to compute its own data, and then this one has its own sort of built-in renderer. There's also the particle lights module, so it's gonna, some particles are gonna have like actual light in the scene. There's the ribbons module, which is similar to trails, but instead of the trail kind of following the path of the particle, it kind of goes through all of the particles, and each of the modules also has its own additional modules. For trails, there's also initializer modules, which are going to initialize some of the properties. They can be simulation modules, which can also modify the trails, over the lifetime. There's not really many, but there's going to be lots that will be added over time. But overall, this is the general structure of the particle system. You start with some, built-in properties. There's emitters, which add new particles. They can initialize some of these. And there's modules. Some of the modules are going to only initialize, starting properties. Some of them compute the properties, every frame, either using the other properties or using whatever internal math or, whatever structure. And then those then get computed to the final render properties, which are then rendered out, as individual points or meshes. And some of the modules, they can follow the particles, they can do some extra stuff, and they have their own renders as well. And it's kind of, how the particle system's kind of put together. And one of the reasons is it makes things, it makes everything a lot more modular. Because if we want to change how color is computed or how position is computed, because the reason I did this is I was actually inspired by the Minecraft particle system, which was shown to one of my friends, a while back. Torn, he showed me the Minecraft particle system, which is a very interesting approach where you can define, instead of, simulating velocity of the particle, you actually define equation where the particle is based on its starting properties. And that's something I want to add to Photon Dust at some point. So instead of, velocity-based simulation, you define an equation that's, for example, based on position, rotation, direction, and lifetime, and you just say, based on these, this is the position of the particle. And it's going to open up, lots of kind of cool effects where you can sort of procedurally define, how the particles move around. And all you need to do is just swap out this position simulation module for the different position simulation module. So the system is designed to be very flexible, very expandable. Some of these modules, like for example, the turbulent force, it literally, it took it was less than an hour to write it. I think it was with a simplex function, it was something like 5 minutes. It's very easy to write lots more modules, which means once the system is out, we can add lots of cool effects. If you have specific way you want to the particles to behave, you can make requests, and now we'll be able to fulfill those requests much faster and much easier than we would have been with the old system. With this, we have there's 7 minutes left, so. We might go a little bit over, maybe. I do want to answer some of these questions. So let's have a look. Let's see. I'm gonna move this over here. So Shadow X, for if there's more questions, time after demo, when I think we'll get more data fit integration with things like component, node browsers, component, node searching without mods would be great. There is something that's planned. This isn't going to happen before the performance update. I would say sometime after performance update, but we don't have a specific timeline on that. Next, Shadow X is lifetime encoded as remaining lifetime that decreases Earth's total lifetime and star creation time. I suppose the latter would make it more difficult to do things like lifetime loss and bounds. So the lifetime is defined, actually, it is defined as the remaining lifetime. So you have the starting lifetime, you have the remaining lifetime, but also the engine does something whenever the lifetime updates, it computes a normalized lifetime. And the reason that is done is because it's used for lots of effects, which don't care how was the absolute time that the particle lives, but how long is it on its actual lifetime progression. And computing that in every module can be expensive because it essentially requires division, which simple operation, but it can be expensive, especially if you do it a lot. So the system sort of pre-computes it. It's just asking fractals. I'm like, maybe you could do fractals. I'm sure like somebody will figure something cool like that. Nyalov is asking, I now need a meta meme that show that particle cube called bitrate obliterator and apply effect to simulate low bitrate. No idea how I can actually do that. The lower bitrate effect can be a little bit like difficult to do like right now, but you probably need to do like either some shader stuff or I mean you could use the pixelate filter maybe and some kind of like distortion, but I don't think it's gonna give quite the same effect. But yeah, these tend to obliterate bitrate, especially if there's a lot of chaotic motion. Shadow X, have you profiled Beppu performance on the headless compared to client? Yes, actually, Cyro ran like some tests, and like it runs really fast. It's very speedy. Do you wanna give more?
Yeah. So just for a very quick context, I was originally playing with .NET 8 before like the headless was like officially upgraded to newer .NET, and I was able to. I spawned like 900 character controllers, and I made them all streamed, and on Mono, even the newest version of Mono, which is like half a decade newer than the one we're using, the server crawled to like 15 FPS with like 900 character controller cubes, and then I switched to .NET 8, and it was like pinned at 60 FPS, and it was like this big gelatinous like cube of character controllers, and like the networking actually broke before the physics did.
That's a lot. Like, it's a lot of data. I remember like joining that session and just seeing this like blob like around, and everybody was like messing with it. It was like beautiful. But yeah, like Beppu, it's optimized for this. Like like it's pretty much right now with Mono, it's kind of handicapped. It's usable enough, but like once we make the switch, like they expect like significant boost like in that alone. Oh, I deleted the question. I have to paraphrase this one because I read it, but I deleted it by accident. Shadow X was asking like, did I wanted to do sticky particles, and it was still on the table for MVP after MVP. Yes, that one's on the table. It's actually much easier to do with the system because now I have like full control. I have some ideas how to approach it. I'll see. It's not gonna be for MVP, but sometime after MVP I can do it. Shadow X, is it gonna be like Spectrum one? I think this was relating to something we're showing. SNB 8272, is it normal for when exiting and saving homes for it to be syncing for a very long time? I mean, it kind of depends. If you change a lot of things, it can take longer. So it depends what you mean by very long time, because that can mean 5 minutes, can mean 10 minutes, it can mean an hour. So it kind of depends on specifics. Nuki-kun, a lot of this stuff is hidden behind lack of array support. When are we going to get updated arrays in Resonite without a mod? So this could happen sometime around like when we rework the inspectors. We're actually gonna rework them using the data feeds. That's gonna make it easier, to actually build UIs for working with arrays. But like any timelines, like we generally don't give specific timelines because those are too like difficult to estimate. So we don't want to like promise specific time which we're then gonna miss. Check the Fox out there. I see color names on the chat as they're broken. Did you figure what was causing that? I didn't get a chance to look at it, unfortunately. Licksquid, maybe you're more debunking. So we know asset storage costs are duplicated across items inventory. Are assets referenced from Resonite Essentials folder counted as free on your storage quota? So it kind of depends where exactly they're stored, but if because the folder does link to some shared folders, but if it's stored directly in Resonite Essentials, those should be free on the storage quota. Anything stored on the official kind of Resonite group, the system should treat it as free asset.
Even if you save it to your inventory?
Yes.
Okay.
Nylov, I don't know the context of that one. Nylov, I think my question got skipped, or I missed the reply. Are you planning to redo iCarry rework right after performance update is finished, or not set in stone yet stuff? Yeah, I did answer this one earlier. We don't have much time, so I can't get into details. It's one of the top things we want to do. It's gonna depend. We're gonna evaluate after we do the performance update. I did answer it in the earlier on the stream, so I do recommend rewinding after this to get the full answer. Next one is SNB 8272. Is there orbiting gravity system for like orbiting moon map? So if you mean for the particles, there's actually radial force. So yes, you can do orbiting. I don't know if I have time to kind of showcase it. I can try it like, real quick. See like, if I can open this up. So with emitter, I'm gonna add, this is like a speed run because like we have only like a minute left. Oh, we have 10 seconds left. Yeah, there's probably not enough time. I'm just gonna show you a radial force. I'm gonna drop this one in, see what this does. If it doesn't work, they might need some more like messing around. This radial force, I'm gonna eat the trails, not trails, the simplex one. Eat this one. Radial force, that's gonna be stronger. And might not work right. Yeah, it is not working, so I need to mess around with this a little bit more because we moved a bunch of stuff. So that's pretty much like all the time we have, like we're now a little bit over. Thank you very much, everyone for, for like your questions. Thank you very much for watching. I hope you enjoyed this episode of the Resonance. I hope like you enjoyed, learning more about the new particle system that we have, and that you're gonna enjoy, messing around with it and playing. So thank you very much, for building cool stuff. Thank you everyone for how did help participate in the testing. There's a bunch of kind of issues that I'm going to be going through over the next week, and hopefully get a Photon Dust released. So thank you very much again for watching. Thank you, Sarah, for helping me co-host. Thank you for supporting this platform, and we'll see you next week. Bye-bye. Thank you very much.
Bye-bye.
What?